Hello, this is question number 38 from 2022 paper. So we have let xn be a sequence of real numbers, and you have considered the set that P where n belongs to the set of natural numbers and x is xn greater than xm for all m belongs to n with m greater than n, and you have to find which of the following is true. So let us consider. So we have the xn sequence. So we have considered the sequence. So this xn. So we have to find what if the p is finite and what if the p is infinite. So we will check with that. Suppose xn is equal to, you can define this sequence as minus n, where this you can write this as minus 1, minus 2, minus 3, minus 4 in this one. Right. Now we have this condition. This condition is m greater than n and xn greater than xm. So from here we can say that 2 is greater than 1, and from here we can say x1 is greater than x2. Right. From the sequence you can see that minus 1, right, this minus 1 is greater than minus 2. Right. So the 1 belongs to this set of P, is element of P. Similarly, if we put in this way that x2 is greater than x3, which implies that minus 2 is greater than minus 3. So this implies that 2 is an element of P. Similarly, 3 is also be an element of P if we do this x3 greater than x4. So this 1 element of P, 2 element of P, 3 element of P. So what we can write, this P is equal to this 1, 2, 3, and it will go to infinity. So from here we can find that P is infinite. Okay. Now if P is infinite, then xn has a monotonically decreasing subsequence, or then no subsequence of xn is monotonically decreasing. So let us consider a subsequence of xn. So the sub of xn, we can write it in this manner, that x of 2n plus 1. So this is the subsequence of xn. So now put the values of here. So we will get minus 3 for n equal to 1, minus 5, minus 7. So up to it will go like this to infinity. So this subsequence, what is this subsequence of xn? So this is a decreasing subsequence. It is a monotonically decreasing. So in our case the option is P. If P is infinite, then xn is has a monotonically decreasing subsequence, the option C. Now whether we have to find that P is finite. Okay. So let us check with this whether P is finite, and we will check that in the subsequence. So let us consider a subsequence written as minus of 1 by n. So we can write it in this manner also. This -1 minus half -1/3 -1/4 up to this. Again, we have the same condition over here. This x1 x is m is greater than n. Okay, so m is greater than n and xn is greater than xm. So it is clear from here that 2 is greater than 1, right? So here you will find that xn to be finite, xn means x1 so x1 is less than x2. Why? Because -1 is less than -half. This implies that 1 is not an element of. Similarly, for the same portion, this x2 is less than this x3. This implies that half is less than -3. So 2 is also not an element of P. So similarly, this 3 is also not an element. So in this way, you can find that what will be the P then? P will be nothing. It will be an empty set, that a phi set, right? So P is finite, so it will be an empty set or null set, empty set, this way. So now let's take the question that if P is finite, then what its subsequence will have. Then option A is given that xn has a monotonically increasing subsequence, and if P is finite, then no subsequence of xn is monotonically increasing. So let's check with this. So subsequence of xn we can write in the same manner. X of 2n plus 1. Okay. So it will be, if we put the values over here, so it will be -1/3 -1/5 -1/7. Okay. And it will go like this way. Right. So this value, you can see this. What is this 1/3? It is 0.33. It is 0.2. It is something about 0.1. Right. So this is an increasing subsequence. Right. The increasing subsequence, monotonically increasing subsequence. So in both the option, in both cases that it is fine, you can. Option C. So what will be the correct option? So for the option A, P is finite, then xn has a monotonically increasing subsequence. That is one of the correct option for 38. Option A is correct. And if P is infinite, option C, then xn has a monotonically decreasing subsequence. So option C is correct. So for question number 38, option A and C both are the correct options. So question number 39, say let V be the real vector space consisting of all polynomials in one variable with real coefficients and having degree at most 5 together with the zero polynomial, and so T be the, so let T this belongs to this V which is the real space, and it is linear mapped. Okay, so we have the condition t1 equal to 1, and we have given the equation over here. So we will start with this t of x x minus 1 to x minus k plus 1, and it will be equal to 1. So the k range is given, k from 1 to 5. So it will be true, this t, the function, will be true when k is equal to k minus 1, right? So this will hold. Similarly, we can write that t of, for k equal to 0, k equal to 0, t of x will be 1, k equal to 1, t of x minus 1 is equal to 1, k equal to 2. Similarly, we can write t of x into x minus 1 into x minus 2 is equal to 2. So is equal to 1. For k equal to 3, t of x into x minus 1 x minus 2 x minus 3 equal to 1. Similarly, for k equal to 4, t of x minus 1 x of x minus 1 x minus 2 x minus 3 x minus 4 equal to 1, and k equal to 5, that will be t of x minus 1 x minus 2 x minus 3 x minus 4 is equal to 1. Okay, so from here you can see that k equal to 1. So if we simplify this, k equal to 1, t is x square minus x is equal to 1, and we have told that it is a linearly mapped, so linear, so it is a, the function is linearly, it can be linearly transformed. So this, you can see the linear map defined by t1 equal to 1. So this is also a linear transformation, so we can write this manner, t of x square minus of tx is equal to 1. So t of x square is equal to 2. So tx is 1, we know. Similarly, if we go for k equal to 2, so that will be x of x minus 1 into this multiplied by x minus 2. So if we multiply this thing, x cube minus 3x squared plus 2x is equal to 1. Similarly, if we do apply the linear transformation over here, x cube minus 3 of 2x squared plus 2 of dx is equal to 1. So from here we can find this t of x cube, which is, so 3 over here, so tx square you find 2, you will find that tx cube will be 5. Now if we put for k equal to 3, so for k equal to 3, so we will simplify the equation, this one, okay, so it will give as t of x to the power 4 minus 6 x cube plus 11 x square minus 6x is equal to 1. So if we apply the linear transformation, so it will be 11 of t square minus 6 of dx equal to 2. So this, from here we can write tx to the power 4, the value will be 50. So let's check the option. So we have find these two values over here. So first one is the tx square, t of x cube t of x4, and we have already value of tx. So in our case the correct option will be B, A and B, right? So A is to what x4 is 15 and for x cube it is 5. This is question number 13. So question number 40 says that let P be a fixed 3 cross 3 matrix with entries in R. So which of the following maps will be linear? So we have to find from the following options which of them are linearly transformed. So let us consider M as this M1 plus lambda of M2. So if T of M1 plus lambda of M2 can be written in the form T of M1 plus lambda T of M2, then we can say that this M can be linearly transformed, or it is linear. If we do the mapping from M3 to M3, it will be linear. So we have to check with the following options. So first one we have to put for 3, this T1. So we can represent T1 of M as T1 plus lambda of M2. So it will be M1 plus M2, say MP minus PM. So M1 plus lambda of PM2, it is the M, into P minus P into M1 plus lambda of M2. Now we keep all this side, so M1P, we organize the equation, so M1P minus PM1 plus, if we take lambda as common, so M2P minus PM2, right? So this is, yes, it can be written as T of M1, right, plus lambda of T of M2. Right? So in our case the option A is correct. So it can be linearly transformed. So now coming to the option B. So if we write T2 as M1 plus lambda m2. So I have to put a square this m1 plus lambda m2 square p minus p square lamb p square m1 plus lambda m2, right? So now if we simplify the equation, so m1 square plus 2 m1 m2 lambda plus lambda square m2 square p and p square minus m1 plus lambda of m2. So here you can see that we have a term of lambda square. So over this, if this is a square term, this is, so you can say that this option number 2 T2, it cannot be linearly mapped. So this doesn't obey the law of linearity, you can say. So this doesn't obey this thing. So any expression whichever this something like that m square or m cube, you cannot consider those power terms, because so in the option from the option B, it is clear that it is not linear. Now coming to option C, so for this T3 is m1 plus lambda of m2, so mp square, so the m1 plus lambda of m2 p square minus p square of m, the same lambda of m. So if we reorganize this, m1 p square minus p square m1 plus of we took lambda common, so it is plus m2 p square plus p square m2. So it can be written as similarly as T3 m1 plus lambda T3 m2. So in our case the option C is also correct. This also it can be linearly transformed. Now checking with the option D, so we have mp square minus pm square. So just we mentioned that in the option B and C you can just check with the expression that m square. So here we have this lambda square will be present, so which means that they are not linear. So in our case D is not the correct option. So for the question number 40, the correct options are A,